Okay, so here's question 3. So this question concerns the elements of group 7 of the periodic table and their compounds. Symbols W, X, Y, and Z represent the halogens fluorine, chlorine, bromine, and iodine, but not necessarily in that order. The diagram below shows some reactions of halogens W and X. So this question is based on the displacement reactions of the halogens in the main. So you need to understand in this instance that the elements in the top of group 7, so fluorine, chlorine, are more reactive than the ones towards the bottom of the group. And if the halogen itself is a molecule, so chlorine, bromine, iodine, or the other one, which I've forgotten, if they're put into a solution of a less reactive halide, okay, so this is where the halogen is formed part of a compound, then the more reactive halogen will displace that halide, becoming a halide itself and displacing the other halogen. So if we have a look at this one, we'll start in the middle. So halogen W, if it reacts with sodium iodide solution, okay, we get a solution of W minus ions. So that tells us that halogen W is more reactive than the iodide, okay, and therefore does displace it. So halogen Y must be iodine, okay, so halogen Y must be iodine, okay, so we can put that one in. Okay, so we know that Y is iodine. If we look at this reaction here, we know that halogen W reacts with sodium bromide, and again we get a displacement reaction because the halogen becomes a halide. We know that because we start off with an atom, if you like, and we end up with an ion, okay, and halogen X, okay. So halogen X must therefore be bromine, okay, because it's been displaced from the bromide to become a halogen, okay, so that's bromine. And then if we have a look down here, okay, we've got halogen X, which we know to be bromine, reacts with sodium iodide solution, okay, and that gives a solution of X minus ions and halogen Y. Okay, so actually we've not learned anything new here because we've got X and Y already. So let's have a look back at this one. So halogen W, okay, reacts with solution of Z ions. Okay, so at the moment we need to identify fluorine and chlorine, and we get no reaction. Okay, so if we're getting no reaction, that must mean that W is less reactive than Z. We only have two options left, which are chlorine and fluorine, because we've already identified these two. Okay, so if this one is less reactive than that one, then W must be chlorine, and Z must be fluorine. Okay, and that's because W cannot displace Z because chlorine is less reactive than fluorine. Okay, now the next question is similar. Okay, it says when chlorine gas is bubbled into a solution of potassium iodide, there is a colour change from pale green to brown. So what we need to understand from this is that chlorine as a halogen, okay, is more reactive than the iodide, and so a displacement reaction occurs. So where we had chlorine and potassium iodide, we would get potassium chloride and iodine. And chlorine is the green colour, and iodine is the brown colour. Okay, so we could say that chlorine displaces the iodide to iodine, which is the brown colour we see. And we could also say that potassium chloride is produced, but that's a clear and colourless compound, and we wouldn't see that as such. Okay, okay, so that was number 3.